Genomics is the key tool that enables sustainable future.
Because the farmers need to make decisions on all these genotypes, so they cannot wait too long. However, we need to turn to be more useful tools to get the very correctly and quickly.
More precise and efficient breeding will contribute to developing more resilient and sustainable agriculture systems.
One of the big challenges is that the ultimate end users are sometimes skeptical about the value of genomics and are not sure that it'll be worth the investment. And the way we face that challenge is to provide them with a cost-effective service that does actually deliver the outcomes that they're looking for. And so they then see the value in investing in the technology.
We are undertaking a genomics selection project for yellow-feathered chicken breeding using low-coverage sequencing. This project has a significant industrial potential. It benefits yellow-feathered chicken breeding and provide valuable tools for genomic selection worldwide. We plan to select 10 representative yellow-feathered chicken breed from 4 major regions in China: Northwest, North, South, and Southwest.
However, for livestock, I think low-pass have a more powerful result because it have a low cost, can afford the improvement of breeding. Low-pass is a type of whole genome sequencing, but it's not high coverage for all the different parts of the genome. So you only get bits and pieces of the genome. Then typically then what you need for low-pass whole genome sequencing is you need to impute.
Well, it's more cost-effective than high-coverage sequencing, and it provides data that's superior to that can be obtained by other techniques that don't involve sequencing, like the use of arrays.
We compare the performance of MGI sequencer and other companies' products. The duplication rate is significantly lower than others.
Well, where the challenge is the price and the acceptance of the relevance of the data, the MGI solutions really do address that directly in that we produce a low-cost product, but that produces outcomes that people can see and understand when they get the result.
In collaboration with MGI, we did a pilot study on about 50-something animals to compare the concordance between SNP array and SNP probe-based genotyping. The result is highly concordant, the two technologies, about 98% concordant, and have very good R-square as well when we compare the SNPs between the two technologies. We also did low-pass sequencing on about 100 animals. Again, very high concordant.
Well, the great success that we would be looking to is to see this used not only in large projects, but in many small projects that currently can't afford to use genomics, for small crops, in minor industries and small projects. So the technology is at the stage where it's applicable very widely to those more minor use cases.
Actually, in the past 10 years, we meet the next generation sequencing platform, and I found them so turn to be more and more stable and have a very good quality to sequencing some specific position across the genome.
We really need to apply genomics very widely.
With low-pass, I see it as a transition. They need to have a better prediction.
Will bring transformative changes to genomic selection in agriculture.